Hello. Last time we had learned about strings. Today we will see some programs displaying the concepts that we learned in the lecture. For running Java programs, you have to install an IDE such as IntelliJ or Eclipse. Both of these IDEs are available online. Let us see. I have made here a very simple program which is showing some concepts of the strings that we learned the other day. Here I initialize string m1 to hello world. Then I try to print two substrings of m1. After that assign another string variable m2 to a part of m1 plus a new string, and then I assign another string m3 and then m4 and m5. We want to see how does the substring function works, and we also want to see that what happens when we compare strings using double equal to sign and when we compare strings using the equals method as recommended. So in this program, as you may have guessed, m1 is a substring of the hello world. It takes the first three characters 0, 1, 2. So in a substring method call, the first position is inclusive, but the second position is not inclusive. So in M2 we are taking first three letters, for example H, E, L, and then we are combining them with P exclamation mark, which together means help. We are assigning M3 with help exclamation mark directly. Then we are assigning M4 and M5 again with the hello word. We print all the 5 strings and then we do the comparison. In the comparison, first we compare using double equal to sign and then we compare using equal sign. And we want to see the results. We store the result in the boolean and then we print the result. So let us run the program and see the results. As you see, for the first method call where I am taking substring of 0 to 3, I get a printout of HEL, that is first three letters. For second time I only get EL because strings and arrays both start from a position 0, just like in other programming languages like C++. Then I print M1, M2, M3, M4, M5. Now you can see that the value of M1, M4, M5 is hello world, while the value of M2 and M3 is help, followed by an exclamation mark. Later in our program we are comparing M1 and M2, we are comparing M2 and M3, we are comparing M4 and M5, and we are comparing M1 and M4. First by double equal sign and then by the equals method call. Then we are printing all the results. Let's see what results are we getting. Comparison of M1, M2 by either method results us into false. That is not very surprising. Comparison of M2 and M3, where both of them have the same value help, results false when we are using double equal to sign, but results true when we are using equals method call. This is because, as we learned in the lecture the other day, that double equal sign compares the location, while equals compares the value. And because location of the both strings are different, that's why the double equal signs gives us false, while equals method gives us true. Same thing you can later see when we compare M4 and M5. They come true in both instances. As we learned in the last class that strings are immutable in Java, which means that once Java has created a string, then Java keeps it for all the future references. That is, if I keep creating other string variables M4, M5, M6, M7 with the value hello world, Java will keep assigning me the same object that it has already stored. That is the reason why we are getting M4 and M5 both true by a double equal sign as well as by the value. Not only this, if we look at our M1, which was the first time when we assigned the string hello world, even M1 and M4 also come out to be same. You may want to extend this program and compare M1 and M5. You will get the same result as for M1 and M4. The simple example shows you that whenever we want to compare values of strings, we must always use dot equals. It also shows that strings are immutable, that is, once they are created, they live in the memory. Therefore, if you want strings that you want to mutate, please use string builder and not the string constructor. Now let's move on. As we see, suppose we have a class called vehicle. Now you may see that there could be different types of vehicles. For example, car is a vehicle, a truck is a vehicle, and the bus is a vehicle. However, if we want to see that a car is a vehicle, we may want to see that car could form a subclass of the vehicle. Between the car, we again have a choice. There could be a hatchback car, there could be a sedan car, which can then be other subclasses of the car. We use the hierarchy to simplify our programs. We define the superclass which has a functionality which is common to all the subclasses, and we move on down the level by defining more and more functionalities. For example, every vehicle may have some wheels, every vehicle may have some sitting space. However, a car may have some specialized type of wheels, and a car may have a specialized type of sitting space. Then for the hatchback, we go for more definition into the functionalities that we have defined. So how do we create inheritance? You may see the keyword extends. Once I use the keyword extends, my class car becomes a subclass of another class called vehicle. So a superclass, like in the previous example vehicle, will contain most general methods which are common to all the subclasses, and when we extend, ideally we should only mention the differences. In last lecture, we had also studied about different modifiers such as public, protected, and private. When we inherit a class, all public and protected methods or fields are visible to the subclass. However, private methods or fields are not visible to the subclass. A subclass inherits all public and protected fields and methods of the superclass, but it can also add new methods or fields. These new methods or fields are not visible to the superclass. We do something which is called method overloading, so that we can change the behavior of a method that has been defined in the superclass. Suppose the superclass has a method called getWheelsCount. Now a car has only 4 wheels, while a truck has more than 4 wheels. So if from the vehicle we derive two classes, one of type car and one of type truck, then it is advisable that we do method overriding so that the getWheelsCount returns the correct number for two different subclasses. Each subclass can access superclass method using the keyword super. Super refers to the superclass and allows superclass constructors or methods to be called as well. Subclasses must call superclass constructor. Polymorphism. Polymorphism is a concept in Java where an object variable can refer to multiple actual data types. For example, in the previous case where my vehicle was a superclass, and from that suppose I derive two subclasses, one of type car and one of type truck, I can actually have a variable of type vehicle which can refer at some point of time to a variable to an object of type car, at other times to an object of type truck. Java determines at the runtime how to do the correct binding. So for example, if there is a method called getWheelsCount in both truck subclass and car subclass, But if my variable is referring to a truck subclass, then the method of the truck subclass will run at the runtime. However, if the variable is referring to a type of car, then the method of the car subclass will run at that time. If we don't want a class to be extended, we must declare that class to be final. Once we declare class to be final, it cannot be extended and it generates a programming error. Similarly, we can also make a method final so that a method's behavior cannot be changed. If we try to change the reference of one class to another, we need to do explicit casting. So, for example, we can assign a subclass reference to a superclass variable without casting. However, if we want to do it other way around, we have to do explicit casting. The compiler checks that you are not promising too much, which means that what the variable is referring to is the functionality that is implemented and not more than that. Now, let's see abstract classes. Abstract classes take inheritance to another level. In abstract classes, we don't define any methods. So, we only declare them. In order to declare a class abstract, we use the keyword called abstract. Similarly, a method can also be abstract. If a class has even a single abstract method, the class must be declared as abstract. Abstract classes means that no object can be created out of them and only variables can be created of abstract class. These variables then refer to the actual instances of subclasses of that particular abstract class. In Java, we have a class called object, which is the superclass of all the classes present in Java, which means that whatever class you make in Java is automatically a subclass of the superclass called object. Only the primitive types in Java are not object. The primitive types are what we studied in the first lecture: int, boolean, etc. Here are some inheritance guidelines for you. When you are using inheritance, place common operations and fields in the superclass. Try not to use protected fields. If you want to see that whether inheritance is a right approach, try to model your problem as a relationship. For example, car is a vehicle, truck is a vehicle. Because I can directly see the relationship of is a, I can say that yes, vehicle may be a superclass of car. But car, even though it has very much common with a jeep, car is not a jeep and jeep is not a car. So, there is no is a relationship, which means that I should not inherit car from a class jeep or jeep from a class car. The idea is always to make sure that the relationship exists where you want to use inheritance. If you cannot see a very clear is a relationship, then inheritance may not be the right choice for you. Another guideline is to don't use inheritance unless all inherited methods make sense. Let's go back to our example of vehicles and car. In vehicles, you should ideally define all the methods that can be inherited by a car. So, you should not define any method that does not make any sense with reference to the subclass. So, for example, you should only define the methods which denote common functionality. So, you can define a method called get wheels count. You can define a method called get seating capacity, because they make sense for all the subclasses of the vehicle. But you should not define a method in the superclass which only makes sense for certain subclasses but not for the another. Try not to change the expected behavior when you override. So, if there is a method called get wheels count, which means that it will return you the number of wheels in a vehicle, please keep the same meaning when you override it in a subclass. That is, try not to change the implementation to get the seating count from the same method. Java will not stop you, but this is not a good programming practice. So the last inheritance guideline is to use polymorphism in your program wherever you can. Thank you.